This lesson is on quadratics. Quadratics are used to model several real-world scenarios, and we'll get to that part of it when we focus on the word problems. But for now, let's just define what a quadratic equation is. So a quadratic equation takes on the form ax squared plus bx plus c, where a, b, and c are real numbers. So a quadratic could just be a plain old y equals x squared. We could have y equals 2x squared plus 3. We could have y equals x squared minus 4. So you see here, even though I don't have a b term or a c term written, that just means our value of b in this equation is 0 and our value of c is 0. And we'll get into a little bit later what each of these coefficients actually does to the shape of the graph. Okay, so let's start by looking at our parent function for a quadratic, y equals x squared. So this is our graph, y equals x squared. You can see it has its vertex at 0, 0. Vertex, that is the minimum point on this graph. Some quadratics have a maximum, this one has a minimum. So let's see what happens. What are the different possibilities? So here we have an x-intercept and a y-intercept that are the same. They're both 0. Let's see, when we x squared plus 2. So here, this plus 2, remember our translation theorems, this plus 2 shifted the entire graph up 2 units. And this quadratic has no x-intercepts. So here we have one x-intercept, where our graph is sitting on the x-axis, no x-intercepts, or we could potentially have 2 x-intercepts. Okay, so you can see this quadratic has a vertex of negative 2.5, negative 0.25, and it has x-intercepts at negative 3, 0, and negative 2, 0. So the main features that we're going to be focusing on with quadratics are the vertex and the x-intercepts. And going back to our word problems, that's where we're going to find the most valuable information. Before we get into how to factor a quadratic or how to complete the square or do any of those fun things that we can do with quadratics, I at least want you to see how they can be used to solve a real-world application problem. So let's say that you are a farmer and you need to create a fence. Let's say that this is a side of your barn right here, so you don't need fencing material for that section. And we'll say that you have 200 meters of fencing material. Yeah, it's kind of a big barn, but that's okay. So if you have 200 meters, that means the distance from here to here to here is equivalent to 200. So we're going to call each of these sides x, because they're both the same length. So x and x. What does that leave for this side of the fence? Well, we started with 200, and we are using 2x. So now we have dimensions for this fence. We don't know our value of x yet, but we do have dimensions. And we're looking to maximize the area. So we want the biggest possible fence that we can create out of 200 meters of fencing. So how do you find the area of a rectangle? Just length times width. So area as a function of x is equal to x times 200 minus 2x. So if we were to solve this and identify the maximum point on that parabola, we would know the maximum area that we could enclose this section of property. And we would also know what side or what these side lengths are going to be as well. So we're not going to solve this right now, but I just wanted you to see one of the ways in which quadratics can be used to help in a real-world type scenario.